Everybody, it's time to go for the next talk, but before that, I have more or another prize to give away. So, yeah, more prizes, and this time I'm gonna enlist Will to take out a ticket. I think we need to get a bigger. So,
Wait, what are we giving away this time?
Oh yes, good question. This time we are going to be giving away a 1-year Hack the Box subscription. Because thank you for reminding me to actually say what we were giving away.
My hand's too fat for this. All right. Who has lucky number 2338246?
Woohoo! This guy.
Yeah.
This guy.
All right.
Awesome. I will come get your email.
Okay.
Please, yeah.
So real quick, before our next presentation, I've been asked to make sure that if any of you ask a question, please speak up a little bit. We do have some people who are checking in virtually and want to hear your wonderful questions about horses and ducks and so on and so forth. All right, anyways, our next presenter is Nathaniel Quist. He's a principal researcher at Unit 42 in Prisma Cloud. His talk is titled Shining a Light into Container Cluster Visibility.
Awesome. Hello. It is so good to see people's faces. It is awesome. This is my first conference in 3 years since before everything happened. So I'm glad you're all here. Some familiar faces. Very happy to see some of you. Others, not so much. No, I'm kidding. All right. So first off, we're going to be talking about a little bit about container security and visibility on it. So I just kind of want to poll the audience a little bit. Who's using containers, either Docker or Kubernetes right now? Awesome. Who thinks that we have awesome visibility into containers right now? Okay, awesome. Next question, who's used service meshes? Few hands, all right, cool. I left this relatively kind of high level. There's a few things we can drill down into. I'm always open for questions. And with that, we'll just get started. My beard's gotten smaller. I'm trying to be a little bit more professional these days, I guess. I don't know why. I should just let it grow back and say who cares. But my name is Nathaniel Quist. Sometimes I go by the letter Q. I've actually just recently been promoted. I'm now a manager of the Cloud Threat Intelligence team under Prisma Cloud. We are super dotted lined across with Unit 42. So I work very heavily with Unit 42 and I work with them. I'm actually Prisma Cloud, so it's a bigger umbrella that does all that stuff. But Unit 42 is a lot of fun. Really enjoy working there. A lot of very, very smart people. So yeah, a lot of fun. Some things about me. I like computers. I like cloud. I like RC helicopters. I really love RC helicopters. They're a lot of fun. First time you go inverted and then you actually go up, you're going down right to the ground and you break everything. It's a lot of fun. So, all right. All right, so, all right. A little bit of the agenda today. We're going to be talking a little bit about the dark side of cloud. We're going to talk a little about the challenges that we have with cloud, just kind of in general in the higher view. We're going to specifically zero in on service meshes. And then we're going to talk about a couple other tools that we can actually use to get a little bit more insight into how containers are operating. So the fun side, let's talk about the dark side of the cloud. I thought about doing kind of like a Pink Floyd sort of thing with this, just because it's similar and all that, but I was just like, we'll just stay with actual dark clouds. So, all right, so first off, where are we, just in terms of cloud security, all right? From an Intel perspective, what we're seeing is a lot of identity misuse. So IAM, identity access management, within all of the clouds, within hybrid clouds, there's a lot of complexity that goes into these environments. So with that, we have a lot of leaks, as Greg alluded to in his very first keynote here. Is it your very first keynote? I think it's your very first one too, right? Second one. Awesome. Third. It's even better. Okay. Fourth. It's the seventh. All right. So identity is huge, and it's sold readily, it's easily compromisable, and so that's some of the reasons why we're going to be looking at some of this. Some of these big attacks that we see, IBM, huge breach on clouds, it's like 120 million different credentials are stolen and readily available for cloud environments. It's insane. Mother of all leaks within Forbes. The one that I really kind of want to zero in on the most right here is in SolarWinds, the bottom right-hand corner right here. SolarWinds goes under the radar a lot. Actually, it really doesn't because it's very huge and very large, but when it comes to cloud attack, specifically, it was a supply chain attack, but it was really a cloud issued aspect of SolarWinds. So SolarWinds Orion, which is their cloud offering for hybrid cloud environments, hybrid on-prem cloud environments. And it's how they operate that overall larger structure. And they were able to put a container, an infected poison container, into that supply chain, make it part of the hot fix, and that's how they gained access to not just tens of thousands of organizations, but 40 plus US government organizations as well, including US Treasury, number of different places on that. So it's a very serious attack. And it's also APT 29 or Nobelium, as Microsoft is calling that. So very profound attack when it comes to cloud attacks in general. So some things that I want to look at. These are, I just pulled off of Docker Hub. I actually pulled 50 of the very top most downloaded containers of all time, right? And then I compared these things across Shodan, and I compared that across ExploitDB. So here's the Shodan attacks. As you can see here, Alpine, it's like in a crazy amount of downloads. So just count some decimals here. There's 1, 2. That's 7.8 billion downloads of Alpine. It is the most used OS within cloud operations. Okay, then Ubuntu, and then obviously, Nginx, Python, BusyBox, Postgres. Redis shows up, and it's 3.8 billion, so it's a pretty busy, pretty common sort of thing. Within Shodan, these are how many exposed instances or products across all of these environments. Obviously, Nginx tops the list by a lot. I used a logarithmic scale on this one, so this is definitely in the 300 millions that are exposed. But you can see there's a lot of these particular instances that are exposed. I was kind of interesting that Memcache doesn't actually have any exposures. Maybe my Shodan search was off. Who knows? But it's pretty interesting on this one. So if we go over and look at the exploits, so these are how many are actually available to the cloud or to everybody. If we look at exploits, obviously WordPress is the biggest one, has the most available exploits, because that's awesome. As was it, how many exploits are popped? Like 10 every 5 seconds or so. But there's some interesting ones in there. HTTPD, obviously used pretty heavily. MySQL, which is pretty easy. So if we go back and we look at MySQL, MySQL is sitting at just over 1 million exposed MySQL databases on any regular basis. And yet it's like the third most exploitable cloud container that we have out there right now. So it kind of gives you a little bit of idea on that. I love this graph because it looks very pretty. So what I did is I took all the exposures and I referenced and I cross-referenced all of the different cloud providers that are a part of this one. And I'm just going to point to one of these particular things, and I just kind of want you to see like which one that is. So like this one, this one, this one, this one. No, which cloud provider is that? DigitalOcean. Do we ever talk about DigitalOcean when it comes to exposed and exploitable databases on a regular basis? Attackers use it all the time. Sure, I'll just set this up and we'll have payloads come from there. We'll just use it as C2 infrastructure. But how many people are actually using DigitalOcean as their actual cloud provider? And the biggest one on there, believe it or not, is MariaDB. How much data is held in MariaDB on all of the cloud infrastructure? So there's some interesting layouts and footprints. These are just 20 of the top 50 cloud containers, the most downloaded cloud containers that are out there. So I'm going to pivot from that. That's the scope that we're living in right now, and I want to talk specifically about cloud threat actors. Cloud threat actors is something that is very near and dear to my heart. It's something that I want to define specifically. So we just created a cloud threat report from Unit 42. Myself and J10, who is the other researcher for this. we look specifically at who's attacking cloud environments and if we can quantify them or index them in some way. In order to do this, we had to kind of define what a cloud threat actor is. It's not a normal threat actor. Normal threat actor from NIST 800-150 says that it's an individual or group that is compromising infrastructure that's not their own. So, well, that works for cloud, sure. To be a cloud threat actor, we came up with this definition. An individual or group posing a threat to organizations through directed and sustained access to their cloud platform resources, services, or embedded metadata. You can be a threat actor and tangentially compromise cloud environments and cloud services. Doesn't mean you're necessarily targeting cloud environments. You just happen to spill over into cloud environments. So we wanted to look at what are the actors that are specifically zeroing in, man, that's a hard one, zeroing in on cloud environments. So this is what we came up with. And we created the very first cloud threat actor index. Now, some of these, there's only 5 on there right now, and a lot of these you may realize that these organizations are actual crypto miners, at least that's where they started. However, there's something more interesting about how they operate. If we want to look specifically at TeamTNT, which is the very top one, we're calling them the adept in this particular standpoint. They're considered to be one of the most sophisticated cloud threat actors, specifically for their cloud enumeration techniques and their credential scraping capabilities. It's all bash scripts and it's all very boring and it's very open source and it's like, oh, come on, and they're supposedly retired. We'll see how long that goes on. But their ability to compromise multiple cloud environments, not just Amazon, also Google, very, very impressive in how they're doing that. WatchDog is considered the thief. They're very technically adept coders. They do a lot of Go language. However, they like to steal things too, so they use a lot of TeamTNT access. They'll use Kinsing scripts as well, just to kind of hide and mask their operations inside of those. Kinsing, it's all about money. They're also really good at cloud credential scraping. Rock is an old time, been around a long time. They started out in 2014 as a ransomware called Iron Ransomware, and then they subsequently just kind of moved into cloud. They're still not very good when it comes to containers. They're sort of okay, but they're pretty good at just mass quantities of compromises. And then 8220, which is a spin-off of the Rock, they've returned. They took a break for a while, and they've come back and they've hit pretty strong when it comes to credential access and containers specifically. So what we kind of wanted to look at was we wanted to look at the common tactics that these particular actors use across their environments, and we put these across MITRE ATT&CKs framework. And we found that all of these particular techniques are common across every single one of these particular actor groups. And lo and behold, they're all identity focused, every single one of them. They're all looking for cloud accounts. They're all looking for access tokens, for sessionized application tokens. If you look under the credential access, they're looking for specifically private keys, cloud metadata APIs. They'll just go into that C2 node and just do a metadata pull, and oh, they have cloud creds. It's pretty fun. And then they'll look pretty heavily on discovery as well. But they all have access to escape a host, and they all have access to container and resource discovery. So this kind of led me to this kind of idea. It's like we haven't spent a lot of time talking about the actual techniques that cloud actors actually use against compromised containers. So that's kind of the essence for this particular talk. All of the Unit 42 atoms, all of these particular access groups are part of a Unit 42 atom. It's just kind of a common framework. Everybody's kind of familiar with 6 taxi formats, and it's all JSON encoded, so it's easily decodable. Build it right into your particular security tools. And it's all free, which is pretty awesome. So please go download that. If you want links, please let me know, and we'll give you those links. So here's the challenge that I currently see within cloud. So here's the logic that I kind of want to go down. There are a lot of containers used much more often in the industry. We saw the top 20 list. There's only one of those containers, that being Redis, is the only container targeted application that we know of right now currently for cloud environments. Redis is the only one that all 5 of those particular actors use on a regular basis. The other ones they used didn't even make the list. Was Oracle WebLogic, Think PHP, struts, Apache struts. Those are all very common. Those are all used pretty much by all 5 of those particular actors. However, there's 19 others that are more downloaded and more exploitable than those 5 that I just mentioned. So there's a whole bunch more that's out there. There's a lot more exposed containers in our industry than I think we realized. No one's really looking at DigitalOcean, one, because it's free and cheap, and who cares? And because no corporation's using it, it's all individual people, right? So I know of a few organizations that actually do use DigitalOcean as part of their actual production environment, which I guess because it's cheap. So, all right, so, but my biggest thing is we are not seeing these cloud threat actors specifically target. Why aren't we seeing them target WordPress? Are we just not seeing them? We just don't have the visibility into their particular malware sets, et cetera. So here's the things that I think we're missing. One is everything's fine. Don't worry about it. We're all good. Don't care. Just don't even want to look at it. Another one is that the actors are just better at hiding their tracks. They're just really good at skipping across everything. We're not seeing things. Organizations also have very large gaping holes in their security perimeter in their cloud environments. I'm not going to go into a lot of this why. I can say that identity and access management, the specific roles behind identity and access permissions that organizations across the board, we looked at over 200 different organizations, 99% of them, 99% of IAM policies are overly permissive. It's insane. The number 3 most used IAM policy in all of the organizations right now is administrator access within AWS. In Azure, the number 2 most used identity role, IAM role, is owner. That's access to everything in the cloud. What happens if that key is stolen or compromised? Oh, it's secure. It's in our GitHub, and GitHub is totally secure, right? Sure. Okay. Yeah. All right, so my argument is that we don't have enough visibility into containers specifically. And if we do have visibility into those containers, we are not doing a very good job at offloading that data and analyzing it in any way. And why is that? All right, so let's go to the Rosetta Stone for cloud tools, just real quick. I'm gonna go over a couple. Cloud workload protection. All right, so it is the ability to see actual containers and their operatings in runtime, right? So you can actually see when a container stood up, you can see the process it's running, you can see its network traffic, you can see all that good endpoint detection stuff, okay? So let's say an attacker compromises the front end system. Let's say this is Nginx because it's the most used one that's out there. They're able to move laterally from any number of reasons. Either they go to, they run C and they escape that and go up into the host, and they move over to whatever container. They just move laterally, follow the traffic into that back-end Mongo database, whatever it may be. Inside of that back-end Mongo database, not necessarily exposed to the public, but most likely is, as we saw with like MariaDB and stuff like that. There's probably creds in there in some way. Or you got to the host, and that host has creds available. So we take that dev key, because most likely it's a developer engineer that actually just stood this up, and they just have keys that are exposed in there or just locked inside of that really nice .aws / configurations or credentials, and they just take that key, and then they can then, if that IAM policy is compromised, they can have access to everything that particular IAM role does. If administrator access is that IAM key, which it most likely is, or owner is that IAM role, like it most likely is, they have access to all this stuff. But that's kind of where it stops. That's all a cloud workload protection can give you. It's only an endpoint monitor. It can only see the containers, right? You cannot follow that IAM credential into that larger cloud platform. Okay, that's the end of cloud workload protection. So let's look at what can look at that bigger picture. The CSPM, the Cloud Security Posture Management Tool. This is GRC, or Governance, Regulation, and Compliance for cloud environments. It can see API connectivity, it can see user logs in, it can see hourly scannings of how your particular workloads are configured, all of that good stuff. You can also detect drift detection in a lot of aspects. If something were to change in configuration from start to later on, it'll detect those things, which is great. It also has the cool ability, kind of mixes a little bit with cloud identity services, where you can do IAM monitoring. You can actually see users that are changing permissions. You can see all of that sort of stuff, all in that one single dashboard. So if you look at that, we can see AWS IAM sensitive activities by user. That's great. Where did it come from? We might be able to see a container, But that's great. We don't know what started it. We don't know if there was malware on it. We don't know if they lateral moved to get that. We don't know any of that stuff behind it. That's the end of CSPM. It's too tall, right? It doesn't see the granular aspects. So it can't see workload behaviors. It can see IAM configurations and behaviors. So we're going to look at a couple other tools. These are not necessarily ready for my this particular talk right now, but they're important to know. CCS, which is cloud code security, infrastructure as code scanning, vulnerability fixes, vulnerability scanning, misconfiguration scanning, real-time fixes, obviously, is a huge bonus. You can scan infrastructure as code, your Terraform or CloudFormation or whatever you have, and it can fix it right away. It's like, yeah, go ahead and fix that. Awesome. Get rid of administrator access, or this particular IAM role has access to every single thing in the cloud, just that one specific thing. Least privilege. The cloud network security, also very important. Being able to see that micro-segmentation between cloud and your particular thing is very poignant to the talk today. We'll talk more about that. And then the cloud identity security, IAM, monitoring, enforcement, and cloud, and all its applications. So these are all parts of this larger tool called CNAP. Which I heard a funny thing. So it actually stands for Cloud Native Application Protection Platform. But I had this funny little thing where it was like I was taking a nap in a comfy cloud. And I was like, that's funny because it's CNAP. Anyway. All right, so it combines all of those C tools together. So your network, your identity, your code, workload protections, and CSPM all together into one unified dashboard or UI, which is very helpful. And it can help us do things that are really cool. Like we saw this example before with the CWP. You have your front end, you have that lateral movement over to your Mongo database, exploit the Mongo database, get that credential. Oh, now we log into that particular cloud environment. Guess what? Our CSPM now can see that. So that's the power and the beauty of a CNAP. Being able to take multiple tools and see that chain across events. I would say that, yeah, it's a buzz, tricky term, and I'm trying to leave all the vendory things out of it because I can certainly talk about it. But this is important for all people, especially if you're working in cloud in any way. Get a CNAP, make sure you can see visibility from beginning to end, as far left as you possibly can see it in the dev process, and then as far right as you can possibly see in runtime. So now we're going to talk about service meshes. Actually, I want to stop just real quick. Any questions about any of that? It's a lot of information. We all make sense? We're all happy? Yeah, go ahead in the back.
Going back a whole bunch of, in the beginning with some graphs, why did you put star count as a metric on there?
Star count?
Yeah. So if you, the graph that was showing the most downloaded containers.
Oh, okay.
You also put star count. What the star count is.
Oh,
like,
okay. So, sure. So all of these were pulled specifically from GitHub. Okay, star counts, specific environments, actors will malicious actors will actually try to, impersonate a particular environment. So using a star count as a basis for pulling down your containers, making sure that they're industry reputable, I guess you could say. Having a really high star count means it's most likely to be actually legitimate, just a metric that you can use. I like to see which ones are the most popular that way, which one people actually use. While Alpine is like the #1 most downloaded one, Ubuntu is the most favored by people, right? So just as an example. Any other questions? On CNAPs, we're all good with CNAPs? Okay, cool. Lots of animations. I love my animations. All right, so service meshes. What is a service mesh? A service mesh provides reliability, security, and observability through the organization, monitoring, and securing of each microservices. Basically, how do you organize things? How can you segment that thing? And then how can you monitor and traffic how much is going to that one particular container? They do this, all of them do this through some sort of sidecar. What a sidecar is a proxy that sits alongside that particular container and is able to, the container runs essentially on localhost. Every communication into and out of that particular container runs on localhost. The sidecar is its network gateway across the environment. That proxy connects together. How about this? This is better. You can see ingress traffic coming in here from the left. It hits that proxy A, right? It goes into service A, performs its function, leaves service A, goes over to proxy B for service B. Everything is monitored inside of that proxy. That proxy allows us to do a lot of things. It allows us to load balance traffic. It allows us to do network monitoring on that particular set of traffic. I used Istio on this one. The bottom section, so the control plane, every service mesh has a control plane of some sort. This is just Istio-Ds. They have a pilot, a Citadel, and a Galley. We don't need to go through those for this, but that's just how they control that particular proxy and how traffic moves through that system. There are other security mesh players. There's Consul, Istio, and Linkerd. These are the top 3 most used. Consul is the most widely used across organizations. And I say widely used. The organization HG Insights found that 5,749 organizations actually use Consul. Out of all the organizations in the world, we only have 5,000 that are using one particular service mesh. Istio has about 3,591 organizations that are at least publicly, stating they're using that particular mesh organization. Consul was made by HashiCorp. HashiCorp also did like Terraform. We probably are familiar with that with our systems. They also do Vault, which is a really good secret container for your containers as you're moving through. I personally like Istio. It was kind of co-founded by IBM, Google, and Red Hat. They all kind of worked together to kind of make this particular system. It's super tinker friendly. You can just tinker around with it and do a lot of really cool things. May not be super robust when it comes to development and administrative accesses, but it's like Consul, and it's a little bit more power featured than Linkerd. Linkerd is super lightweight. Basically, it's a proxy. That's what it really allows you to do. But cool tools. There's a few other ones that are out there as well. Built into Istio, there's a number of monitoring programs. Just a quick example, Kubernetes dashboard doesn't come with Istio. It actually comes with just Kubernetes itself. Gives you the ability to see what your resources is, CPU, RAM utilization, all that fun stuff. Going down, Prometheus is kind of a third-party out-of-the-box open source program. It is basically the out-of-the-box favorite for Kubernetes monitoring. We'll give some examples on that. You can monitor lots of things, as I'll show you. Grafana is like a UI interface for Prometheus. Gives you pretty graphics, as we'll see in a second. Kali, I think it's Kali. Would you agree that's Kali? I say it's Kali. Okay. What, Kiali? I like Kiali. Okay, we'll do that. And I like Jagger, just because Mick Jagger, but I think it's Jagger, but that's okay. Jagger? Jagermeister? All right, let's do that. All right, so Kali's really good for container management. It's actually, I think, an undersold sort of system, as I'll show why in a second. It does a lot of good things for security people. And then Jagger is distributed tracing, basically being able to see what one container, how it's talking to another container for how long and how, right? So we'll get into some of these more succinctly. I'm not going to talk about Kubernetes dashboard at all, so we'll focus mostly on Prometheus and the rest of them. This is the basic structure for Prometheus. It's basically kind of like an etcd database, stores everything from a container, and then makes it queryable in some way, some fashion. You can pump everything over to Grafana, which is a POM-QL visual dashboard query language for it. You can do alerting through Prometheus if CPUs got too high on a particular container, or if RAM utilization was overutilized, et cetera. So it does a lot of really good things. Its dashboard is super basic, really basic. Basically, you have this little thing. You can say which specific individual metric you actually want to, look into, and then you execute that, and it'll give you those results of that particular metric. There are hundreds of these. I thought about listing every single one of these things that it can track, and I was like, that's too much. I don't want to do that. All of these things are all searchable within Grafana. Grafana can look at the exact same thing, so I was zeroed in on API server, watch events total on the last screen. These are the instances that it can see. You can see that there's specific internal IP communications between which apps are communicating with which apps. This is all available within Istio or whatever proxy you're using, and it gives you this kind of insight into how communication or how containers are communicating with other containers in your environment. Cool little Grafana. We've all seen Grafana, so I don't need to go into that. It just looks pretty. It's what you put on when the sea level comes in, and you're kind of like, yeah, I'm doing work, see? And that. But something's missing, right? I mean, this is really good insight and really good information for managing and administrating these particular systems. But that's really all we kind of have. We don't have any endpoint connectivity. We don't see what processes are happening. We don't see who's connecting with any of these particular systems from outside or whatever they're doing. So why not? Here's Jaeger. Very similar. I could zoom in on this. Essentially, it gives us kind of the same information. This is how one container is communicating with another container. This particular container, this is how Kiali, is that how you said it? I like Kiali. Kiali is speaking with Prometheus. They had a 1.2 millisecond communication span from which IP address. They had their whole header information. We're getting closer. We're getting header information. We're getting some cookie information, which is great. But again, it's just how containers are communicating with other containers. If an attacker were to compromise a container and move into another container, you could probably see that traffic in Jaeger, maybe. But again, something's missing on these. This is where Kiali comes into. It's a great tool for seeing how Istio is working from a visual level. This graph right here, you can see each individual little graph. This is just the book info, which is just a standard application that comes with Istio. Just gives you a web page, and you can interact with the web page and see how data moves through. All of these little cool things are, they're all animations, so you can actually see like little packets moving around, and it's really kind of interesting. But the cool thing that Callie lets you see is there's a little lock. You can see it like right there and right there. Every single one of these communication pathways between all of these containers is TLS encrypted. There's micro-segmentation between every single little container going through there, which is great, right? From a security perspective, you can't just leak data. It's not going in clear text. It's all encrypted from container to container. That's the beauty of a proxy. That's the beauty of that sidecar technology, be that Istio or Consul or whatever. You can, encrypt all that, and it's all customizable. You can use default encryptions. You can make your own decryptions. You can use your own CA certs. You can do all of the stuff that you want to use, which is fantastic. The cool thing that the mesh allows you to do is able to see that traffic unencrypted, because it's the proxy that makes that happen. All that information comes out somehow, and that's what we're trying to get to. Kylie lets you do that. And also, we're getting really, really close to actually being able to see communication. So what I did is I used from my own little Firefox browser, went and queried my book info system, and I'm now actually able to see my user agent string. I can actually now see who's connecting with this particular system. I can see the cookie information. I can see trace IDs. I can see anything that particular app allows me to communicate, including IP addresses, including domains, if that particular system is configured to do that, or the particular application. I can now see all that information, and it's all stored within Kylie, it's a monitoring tool for administrators, but we can use it as a security team to actually export that stuff, which is pretty cool. This is where this kind of comes in. I was like, how do we actually make a service mesh actual part of our security architecture and industry? This is a simple diagram. You have, it's not simple, but you have your public internet here. It goes through your cloud service provider. I don't care if that's AWS or Google or whatever. It goes through their internal gateways, their internal load balancers before it gets to your system. Then it goes through your Kubernetes system, and then it goes into your service mesh platform. And that will include its own internal egress gateway, its own ingress gateway. It'll have destination rules, so you can actually dictate how you want destination to travel inside of your service mesh. If you only want, let's say load balance, this is the most common reference for service meshes and how they're used in the industry for DevOps people. If you want to load balance a particular new application, a new version of front-end system or something like that, you will say, I want 70% of the traffic to go to my old system, and I want 30% to go to my new system, just to see if I can crash my new code, right? And just kind of load balance it that way. You're not sending all traffic, you're just kind of mirroring traffic off to see how much you can hit it with and break it. How about we use that idea, that concept, to load balance traffic from our applications into security tools like Suricata or Onion or Wireshark or Elastic. We save all that information. So that's what if you can have an endpoint system, have a proxy, you can transmit all information via Istio or Consul into whatever application you want, all network traffic. So kind of a cool tap, and it's built in, and it's free, and you don't have to do anything else. Pretty cool. So here's Istio load balancing. First, we have to make a quick little virtual service. You can see here in the red box on top, essentially what we're doing is we're designating all HTTP traffic that is destined for whatever prod application host, whatever version we're using, or in this case we're using version 1, and all traffic. So 100% of all of that traffic is going to be moved we're specifying where it's going to be moved to the particular prod application and to a security tool. So what essentially we're doing is we're saying, okay, Istio, take all traffic that's coming in destined for this particular endpoint and split it off into two things, into that endpoint itself and then off into whatever tool, our security tool. Then we actually have to make the mirroring configuration. Again, this is a service, a virtual service, and we're saying, again, all traffic from prod in V1, we're going to send that to security tool, and we're mirroring 100% of the traffic. That's as easy as it gets. You try to do that in AWS, you have to use port mirroring. You can do one port, and it's insanely expensive. I don't know whoever's done AWS port mirroring. It is like ridiculously expensive to do that. So you don't have to. Istio will do it for you. Then you just feed that off into Splunk. Look at that. We've got all of our header information. We've got IP addresses. We've got all that information. Now we have where it's coming from, ports it's coming over, all that pretty amazing stuff. Just pipe it into whatever centralized information system you want. I think that's pretty cool. It's a way to really gain visibility into your cloud, into your containers. But that's not the only tool we have. So I'm going to leave Service Mesh here a little bit. I'm going to look at other tools that we can use. There's something called eBPF. Anybody heard of eBPF? Cool, a few of you. What it does is basically makes a sandbox for Linux binaries, and it launches them in its own OS kernel. With that, you can see everything that is happening inside of that particular container, inside of its own little kernel, its own little tiny little sandbox. You get all the networking information, you get all the runtime information out of that particular system, you can see the kernels, you can see all the library calls, you can see, I mean, everything that's happening on it. And also traceability and serviceability. Here's a few different tools. Falco, probably the most common, everybody knows about it. Aqua, my competitor, Greg's competitor, they have really cool tools called Tracy. There's another one, Trifago, I think is what it's called, and it's made by Cilium. Pretty impressive. So yeah, there's a couple different ones. A couple different applications. Again, it can do tracing, profiling, monitoring. It can run OS. It can map fires. Basically, it's a really cool trace program for containers or Linux environments. They just happen to run inside of containers. This doesn't really work, unfortunately, for Windows systems, but as our recent reports have found is that we're looking at 86% of all of the cloud is running under Linux. So Windows. Sorry, Zach. Apologies. But go away. No. Linux is where it's at. All right, so eBPF is really cool. So the information that you can get out of this, I know I should have highlighted specific things on here, but it's cool. You get this nice little JSON format of all this really cool information. We're going to zero in on a couple of those things. You can see here that, look at this. The origin is running from a container. You actually put this on the host, it can see everything on the host, and it can see everything happening in every container underneath that host. Here's another example of that particular thing. Cool things, you can see which node it's running on. You can see that its origin on this one is running host. You can see that that host is running PS, the PS command on that particular host. Inside of the container, you can see that it's running BusyBox. So that's pretty cool. Now we can actually see which containers are doing what in that environment. You also get the nice cool hash values, all of that. Cool thing is here, again, run that into Splunk. Again, you can use whatever tool you want to use. You can see that everything the container is actually using, and you can see everything the host is using underneath that, which commands are running those particular systems. So the hard part is just installing this eBPF tool on your host and then making it report back to your particular interior. I could talk more about that. We're having a really cool honeypot project that we're working on where we go really deep into this and how to map all this out. But some cool stuff. So if you have questions about how to make that work, hit me up after this. I'm going to talk a little bit about commercial tools. I'm sorry, I'm going to have to, because there's some really cool things that are out there, and I really want to highlight some of these things. This is Palo. It's my company, so it's just, shout out to my provider of my paycheck. Wildfire threat intelligence feed is very, very impressive. Unit 42 curates it. It's a very impressive tool, really good threat feed. If you're using kind of a micro-segmentation technique like a CN series firewall or something like that, I'll get to in just a quick second, if the Wildfire, your threat intel feed feeds right into that. That's the point that I really want to make. Whatever threat intel feed you're using, whether you're using Proofpoint or you're using whatever containers or whatever domains are being monitored by that, you can pipe that directly into your prod and into that prod host. Okay, so all your containers can start blocking those domains, those malicious things right out of the gate. Pretty amazing. Big bonus. If you're looking for just micro-segmentation, if you just want to go in line, if you want to work with Istio or Consul or something of that nature, you can have your, your specific pod running whatever containers you want to be running on that, running specific services. As it's going through the proxy, have your Envoy proxy send that to your particular cloud monitoring agent, whatever that is. In this case, just for simplicity, using compute, just because you can have compute start monitoring those domains, those hashes, all that stuff that's happening, and then block those things, allow them to go through, redirect them, do whatever you want, as they're moving on to your other services across your environment. Pretty cool stuff. So to recap, containers are targets, as we can see. I mean, there are very big targets. There are big actors that are specifically targeting these environments. And I'm not even talking about the big actors, right? I'm not talking about, APT29 or 28 Cloud Duke malware, which is very impressive, targeting a lot of Azure space, using a lot of Azure storage blobs and things of that nature in order to host malware and go through that, or specifically targeting Google creds. There's a new Chinese, I think it's, APT41, targeting specifically Google passwords and credentials. So there's specific nation-state actors that are doing very specifically targeted information, not just the actors groups that we're looking at with TeamTNT and WatchDog. They're just kind of, let's be honest, they really are just kind of like, oh, I'll just take as many creds as I want, and I don't care who I'm targeting, I just want information. And then they sell that or whatever they're doing with it. But they're gaining access to that cloud, that top level environment. There are full spectrum monitoring capabilities inside of containers right now, be that Kubernetes dashboards, Prometheus, Grafana, Jaeger. You can see performance capabilities and metrics. You can be able to see communications from container to container, which could be helpful if their lateral movement are compromised. Kylie is really impressive. It's starting to give you the ability to look at those access logs within the Kubernetes dashboard, being able to export those out to your environment. But the key thing that I want to take away is that you need to send those logs from your containers to some sort of centralized environment that we can actually start monitoring on, because we're not doing a super good job on that. Service meshes is a very solid option. The cool thing is it adds encryption, it has a lot of security things, adds organization. It's not that heavy. It sounds complicated. The lift is actually pretty simple. If you know how to read YAML, you can do it. It's really that hard. But then please don't forget your other cool tools that are out there, your eBPF tools, your microsegmentation things. Don't forget your vendors. Having that CNAP capability, the ability to see things from that container endpoint all the way to that cloud platform from the very, very tippity top, will allow you to be able to see that migration of actors moving from container to cloud back down to whatever resource that they're looking at, changing keys, there's thousands of different APIs that they could be accessing. And if we're only looking at containers, we're only going to see one aspect of it. If we're only looking at the top level aspect, we're not going to see any of the initial compromise. So there we go. So that's it. That's my whole talk. I think I'm doing well on time, actually. So I think we have any questions available. Cloud containers, service meshes, anything like that. Go ahead.
So in terms of AWS API keys, do you guys have any visibility into where you think maybe those are being stolen from? Or would you venture to guess on any avenues where attackers are gaining access to those?
So just from the actor groups that we've been able to see, and this includes Nobelium with SolarWinds, is they compromised either first start with that GitHub sort of aspect, take those angles, take social media, their social outlets. There's always keys. Even though GitHub is really good about scraping credentials really fast, it usually takes them about an hour or so to start modifying those things. So they're always there. Initial they're there somewhere. It's really easy. ShushGit is a really easy tool that you just basically do an API token into GitHub and you can find interesting things. Lots of cool tools in that aspect. Compromised cloud instances is always a really big, easy avenue to get to. TeamTNT is an example. Within I mean, it was just within a few days. They had over 9,000, compromised cloud endpoints. And they do that specifically by scanning, compromising, gaining cloud, tools. And they sent their tools off, they sent their creds off to their C2 node. You could log into the C2 node using their own tool, and you can see how many, and they had thousands of cloud identities and accounts. So we're really at a point right now where it's really basic, that we're just storing our credentials in .aws /credentials, .g cloud /credentials. Most of the clouds in cloud, exposed clouds instances are just stored in those particular places. If they're not there, just reach out to Metadata API, pull down your credentials. It's really easy. If you want to try it, go to your own EC2 instance, go to 169.254.169.254 /metadata /credentials. Look at that, you got your credential. So it's pretty straightforward. Unfortunately, there's a lot of opportunistic actors right now, and I kind of go through like the business email compromise that Greg was talking about. Really easy to compromise a lot of stuff. Very simply, it's not really that hard. You can just go in and go to VirusTotal, download somebody else's script and use it. It works. It's pretty wild. Just make your own wallet and then off you go. But crypto mining it's on the decline. Ransomware's picking back up. So I'm just waiting for the actors to actually start using something else other than bash scripts, actually start using more Golang, use more ELF binaries to actually do their work, which it's starting. It's going to happen. Any other questions?
What would you like to see in terms of functionality so that you have more clear oversight of the communication that's occurring? Like,
yeah.
What things do you think could make that easier, or what open source communities might be able to?
Okay, so so repeating the question, the question is, how can we make it easier to communicate between cloud and security tools? I think kind of potentially is kind of your question. How do you make things easier? Cloud, I'm not gonna lie, cloud is complex, and the complexity makes some people very nervous about doing things. But cloud is 64% of our internet right now. It's an amazing amount of the internet that we actually use on a regular basis is cloud. We're already there, and so being able to gain education visibility into this. That's why I hope this talk is a little bit helpful, because things like service meshes are very helpful in organizing and compromising these. You can only see that if you take all of those tools together, all these service meshes together, from one source, there's basically 10,000 organizations in the world that are using these tools. And they're very helpful. They really help security. They help give visibility into tools. So the education, being aware of these things, cloud actors are compromising environments, and they are making money off of it, and they are selling your credentials for cloud environments. And most credentials are administrator access, which means your entire cloud infrastructure is probably compromised. So that should be scary, and I want to be very clear that should be very scary, because it scares me. And I think that the cloud service providers are doing a really good job I really do think that they are doing a very good job of trying to educate people in what that shared responsibility matrix is. What are you responsible for? What is the cloud environment responsible for? Essentially, the cloud provider, AWS, GCP, Azure, is responsible for giving you the infrastructure. Full stop. You are responsible for IAM. You are responsible for how your applications are configured. Zach.
Yeah, like of the compromised things you see, like, can you gauge what percentage of them are used directly by the actor who compromised versus like the credentials are sold, or maybe both, where they're kind of double dipping?
It kind of goes into the CNAP. Visibility is a problem within cloud environments. Being able to know that. Being able to see in the cloud environment and know if a credential was used by a specific person that was bought by somebody else, or not bought, that's terrible English, bought by somebody else. I don't know if we can see that. You as an organization would have to have a good record of where your identity access management policies or your keys or your access is coming from, and then notifying or flagging when something is amiss using some sort of anomaly detection that a cloud service provider or that a cloud service posture management CSPM tool would help, could give you insight into. Of like say TeamTNT, WatchDog, ROC, we are able to see their tools when they do compromise a cloud instance, if they are then subsequently accessing the larger cloud environment. TeamTNT most certainly is. ROC, we're not terribly sure yet. WatchDog, following suit with TeamTNT, probably is as well. So again, visibility is a problem. Again, we need to make this information more readily available. Question?
Naive question or stupid question maybe, but since if you're doing a service mesh and you're able to actually see all the data because of the TLS, what are the ramifications for PCI or HIPAA compliance on the access on the log for audits?
Good question. So the question being, if you're using TLS for communication between containers, how do you handle PCI for HIPAA, or compliance for HIPAA or PCI? Intercommunication, I guess it depends on how you between you and your insurance provider for your if it was compromised. You are providing doing diligence by providing encryption end to end. It is a matter of you recording that communication or not. Doing best practices to say if something was compromised, how do you pull it down and actually know that it was compromised. Again, you have to be using a service mesh to begin with. That would purely be due diligence on your part. But it would satisfy PCI and HIPAA by having communication.
And the audit requirements are access to the data, which now require access to the logs.
Right. So the logs are stored. Kubernetes does store the logs in their access log format, which is an etcd format. So it is there. It is stored. And you'll be able to prove that it happened and that it was encrypted or not encrypted. Kubernetes will hold that. Or you can pull it off to a third party.
We can maybe do one last question.
Cool. Awesome. Well, thank you so much for your time. Appreciate it.
So we are about to break for lunch. Real quick, before we forget again, we are donating a lot of the proceeds from today's conference to Silicon Flatirons. If you're not familiar with them, they're a really cool organization, kind of based here. Actually, if you're wondering why we're in a law school of all places, it's because we got some help from them getting this great venue. So if you get any of the swag upstairs, or if you see any of the various bits and pieces of Silicon Flatiron's stuff that we spread about, please consider donating through the PayPal QR codes that we've spread out all over the place. But yeah, anyways, there's lunch upstairs, but it's Snarfs, that's it. Yeah, it's Snarfs. Snarf sandwiches. Anyways, go nuts, and we'll be back in an hour. Thanks.